Welcome back, guys, to our another lecture on Java. Today we're going to be looking at the Stream API, and this is one of the important APIs or invention for the Java language, and this was added in Java 8. And if you are aware of code that used to exist without strings, and you see what Stream API can do for you, you will definitely start using the Stream API. You see that it simplifies things for you. You can do like wonders with the Stream API. So we are going to look at the following contents in this subject. So what is a stream? A stream is a sequence of objects. Stream operates on data source such as an array or collection. Know that the stream itself does not provide storage for data. The stream simply transforms data in some way. Or you can think of a stream as a pipeline. When you have a pipeline that transports water, that pipeline or that pipe itself does not store the water, nor does it provide the source of water. It simply transforms or transport the water from one point to another. So that's basically what the Stream API does. So the Stream API has what we call the BaseStream. This BaseStream is at the top of all the stream classes. So what it does, that BaseStream, is it provides basic functionality available in all streams. And you will notice also that it extends AutoCloseable, which means you can use it with with resources, and the stream will be automatically closed for you. So now we also have the primitive streams. The reason being because the stream operates on object references, not primitives. To handle primitive type streams, the following are provided: the double stream, int stream, long stream. So if you have a list or a primitive stream that you want to convert into a non-primitive stream, you will have a code like this: int stream, let's say it's just an int stream, and then you just call a method called boxed. It will just convert it to the non-primitive stream. So let's see this in code. So as you can see here, we have long stream dot off, then we boxed it, then we have stream long. If we make this to be an int string, we will have to change here to make an integer, then our code will work. This is what we mean by you're converting a primitive stream to a normal stream. So since JDK 8, we know that the Stream API was added in JDK 8. And what they did was that they also added methods in the collection interface to enhance the stream. So those methods, we see that is so what those methods do, they will return a stream based on the underlying collection that you are working on. So we have those methods are default inside. So we see that we have stream E, which returns a stream, and this is a default implementation that returns a sequential stream. Then then we also have stream E parallel stream, and then we see that the default implementation returns a parallel stream if it's possible. If parallel stream can't be obtained, sequential stream is returned. So the idea to return parallel stream will be determined if your computer architecture allows it. If you are in a multi-core system, then parallelism will be achieved only if the environment supports it. So Also, it is important to note that all streams are executed lazily. That is, they require a terminal operation to execute the stream. I'll just give an example for this. Let's say we have the stream, and then we say integer stream dot let's just say we say dot filter, then we can say anything p. I'm just gonna write a basic lambda here. So what we wanna do in a lambda here, we wanna print p, and then what we want to do also, we are going to return true. That means we are basically doing nothing. Then we want to say we can say distinct. If we run this code like this, we're not gonna get any print line on the console. Let's run this code and see. As you can see, we don't have any print line, but we do have the print line here. That means ideally this stream was not executed. But if I can say dot, let's say dot count, observe the difference. Now we get the printing. Why is this the case? Remember, we said they are executed lazily. So all intermediate operations are lazily executed, and they require a terminal operation for them to be executed. So a filter method of a stream returns a stream. And what does that tell us? It tells us that it's an intermediate operation. So an intermediate operation, we will see when we go on about that. And then let's look at count. Count, it doesn't return a stream. What that means, it's a terminal operation. It consumes a stream. As you can see here, it's a terminal operation. So for a stream to be executed, you will require the terminal operation. The distinct method is also an intermediate operation. It will return elements that are unique. So now back to the point. Sequential and parallel stream. So a sequential stream, these are non-parallel streams that use a single thread to process the pipeline. All stream operations are sequential by default, except when you specify that you require parallel stream. So parallel stream. A parallel stream is executed by different threads running on multiple CPU cores in a computer. The stream elements are split into substreams that are processed by multiple instances of the stream pipeline being executed in multiple threads. So parallel streams internally use the fork join framework. So if you have a stream like this, and then you say let's say you have a collection, rather we can say we have collection of integer, and here we say arrays as list. If you say collection dot stream, and if you say collection dot parallel stream, this will give you different behavior. So if we observe this in collection, it says returns a sequential stream with a collection as its source. This method should be overridden when the Spliterator method cannot run as a Spliterator that is immutable concurrent. Okay, we'll look at the Spliterators. For now, let me also come here you see that it returns a parallel stream with a collection as its source. It is allowable for this method to return a sequential stream. Alright, that is, now the sequential stream will be returned if your environment does not support the parallel stream. And under the hood, as we mentioned, the parallel stream uses the fork join to actually process your stream. So if we were to say, okay, we'll look at that later. Let me not do that for now because we're still going to write code. So we have terminal and we have intermediate operations. So an intermediate operation, you get a string, you process the current stream of data, if any, and then return another stream. That's what terminal operations do. Then we have terminal operation. Operations, as the name suggests, are the last in the pipeline of operations performed on the stream. You can think of them as a reduction operation or consumption operation. After a terminal operation completes, the stream has been consumed. So now, guys, we have seen the differences between intermediate and terminal operations. So let's look at the examples. So intermediate operations, we have map, flatMap, filter, distinct, sorted, pick, and we have many more. Then terminal operations, we have sum, average, max, min, collect, forEach, reduce, findFirst, findAny, allMatch, noneMatch, and many others. So all these methods are what we call terminal operations because they work on a stream, they consume a stream, and they return some other object. Then we have iterator also with streams. Although a stream is not a data storage, you can use an iterator to cycle through its elements the same way an iterator is used with collections. And the stream supports two iterators, the iterator and the Spliterator. So the Spliterator was added in JDK 8. So the only difference between the iterator and the Spliterator is that the Spliterator, what it does, it also partition element. So it's an object for traversing and partitioning elements of a source. And it offers an alternative to iterator, specifically when parallel processing is involved. And it's a bit more sophisticated than an iterator. So basically you have a way to split your data that is incoming into partitions, and you can work on it in partitions rather than working on it as a whole. And this requires a multiprocessing environment that will require you to have parallel processing. Then advantages of Spliterator. Unlike iterator and list iterator, it supports both sequential and parallel processing of data. Compared to other iterators, it provides better performance. Thank you.